I'm ready. Let's just see what we
Awesome.
can do. I studied for 10, and then just started 11, and then I realized, and then my phone actually made a funny noise because you did the whole call thing. It's my Google thing on there, and I was like, oh, 8:15.
No
Um,
problem. I
okay.
went through both, but I feel like this is all new to me. I've never taken this class before, so I feel like I'm always like the graduate of our group. So,
Oh, you're fine.
computer. But so, do we want to just go ahead and say 10?
Yep. Assume 10. Okay. So 10 prep assignment. Okay, here we go. Awesome. You guys want me to just start reading?
Yeah, that'd be great.
Yep.
Okay. Lesson 10, prep assignment, part 2. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? Gosh.
Is that going to be the same as number 4 on the individual prep, that it needs to be a simple random sample?
Yeah, I wrote.
Or is it different?
Confidence. I wrote all of this down. I just need to find it in my notes. Like, I took so many notes today.
Yeah, there was a lot of stuff to look over.
I took like 6 pages of notes. So,
That's awesome.
and
This is for confidence intervals, right? That's what it said.
yeah.
This is for what are 3 assumptions you need to check before you compute a confidence interval for a mean?
It is a simple random sample population for the sigma or the standard deviation is known. Either of the conditions are satisfied, population is normally distributed, or the sample size is greater than 30.
30. Okay.
How far down the page was that? Do you know?
I get most of my notes actually from the PowerPoint, and I just skim over the textbook stuff.
Really? Maybe I should start using the PowerPoint.
The PowerPoints are amazing.
Summarizes it a lot better, because I don't. I just read through the textbook every time, and I never look at the PowerPoint, because I was like, I figured the
See, I was
textbook.
doing both, and then I figured that the PowerPoints were more helpful than the book, so I just started doing the PowerPoints.
Yeah, I really like the PowerPoints. He gives really good examples.
Gosh. Okay. Okay. So what were the 3 again then?
I'll give it to you. So it has to be a simple random sample, so an SRS.
Okay.
Sigma has to be known. And it either has to be normally distributed or N has to be greater than 30.
Or a large sample size?
Yeah, it specifically says N greater than 30. So I literally just wrote an N greater than sign 30.
30. Okay. Awesome. Thank you. Okay. So the next one. The Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration programs. A BYUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for these 50 students is 541. Assuming a population standard deviation of 32, answer the following questions. What is the point estimate for the population mean?
So it's just the 541.
541, right? Yep.
Yeah.
It's 8. Create a 95% confidence interval for the population mean. Show all your work below. So that's two standard deviations away, right?
Well, we just use 1.96 in Z, and the equation is Z times, where did I write that down?
So isn't it the equation Z times sigma over N, square root of N?
Yeah, exactly. So it'd be 1.96 times 32 over the square root of 50.
Okay.
I'm getting my calculator.
And do we do the x plus or minus?
Hang on. This is just to get the margin of error. So
Let's see. Square root of 50. Okay. So 50.
I got 8.86995. And then I'm trying to figure out if we need to do the both ends of it.
What did you get? 8.869?
Yeah. 9.
So what was the equation again? So this is z times theta over the square root of n?
Yeah, correct.
Times sigma over this.
Okay. Or sigma, that's what it is. I keep calling it theta. Sigma. Whatever. So 32.
Yeah, so I guess that this is just the and we still have to solve for the other one. So I don't even think this is the right equation. I think that, are we supposed to do the x bar minus c times sigma divided by because the answer is so this would have just been solving for error. And what we really need is the confidence interval. So it's actually
You know what makes me want to do right now? Make you get in a lot of trouble. Because you lied to me.
What did they get for their What was the answers on the?
the answer on the answer key is 534.73 and 547.27.
Oh, wow.
Oh no, sorry. It was 532.13 and 549.87. But I think that we're supposed to use x bar minus z times sigma over the square root of n. And then the other side would be x bar plus
Yeah.
margin there. So I just don't know what we'd use as x bar.
Is that our 50?
No, that's our sample.
Oh, that's our sample size.
So in hang on. My computer's like being really dumb. Because on the link she has like the answers and how she worked it out, so you can kind of work it backwards, I guess. Let's see.
Okay, I think I understand
Wait,
how
is
to do it.
x bar our sample mean? The 541?
That might make sense. Yeah, I like that. 541, and then we could just plug in the math we just did, since that's
So 8
so it'd be plus or minus that 4. 8, 7,
So if you do the plus, it's 549.86.
It should be 549.87.
Okay, yeah, then that's, yeah. Because it's 869.
And then the other one, if you just subtract it, it's 532.13.
532.
Pretty much
Yeah,
did one part of it and then added F bar. So cool. Did you get that, Matt?
so 8.8699 is the number, and then you plus and minus that, right?
Yeah, from the mean. So 8
So you
point.
figure out Z, and we can use like the normal probability applet, right? Because it's greater than 30 for the N. And then so it gave us 1.96 times 32 all over 7.07106.
Yeah.
So 8.8699. And then you plus and minus that. So it's 541 minus and 541 plus. Okay.
Yeah.
Okay. Okay. Thank you.
No problem.
Three and 549.87?
549.87. Yep.
Okay. Thank you for holding up for me there. All right. So number 9. Say the sample size changes to n equals 100. Now compute 95% for the same point estimate. So this
541 plus or minus 1.96
over
times
10.
32 over the square root of 100.
So it's 6, so 541. 547.27 and
We got 534.73 for the lower.
534.73. Yeah,
Yeah.
that's what I got too.
Me as well.
Okay. 27 and 534.73. Awesome. Okay, I'm getting this. It's essentially similar to what we've been doing all along. It's just new.
Yeah, there's one extra step in there. It's the plus or minus.
Step. Yeah, now we're just getting ranges and all that jazz. Okay. Hopefully I have enough battery. Let's see here. All right. Number 10. How does the margin of error for the 95% confidence interval for a sample size of 50 compare to the 95% confidence interval for 100?
Well, it increased as our n increased.
I thought it got smaller because
Margin of error was smaller the larger the sample size.
yeah.
Yeah.
So the larger the sample size, the smaller the margin of error. Okay. It says create a 90% confidence interval for the original 50 students. So now, go to 0.9 on the...
0.9 is
1.645.
I got a graph out of the slideshow, so it made it the main one's pretty easy.
1.645, you said?
Yeah.
Okay.
And I assume we're using the same standard deviation at 32.
Yeah.
Okay, let's see. 1.645 times 32 over 7.07, 106.7819. Okay. So then you've got 541.
Did you guys get 7.444 for the margin of error?
Yeah, I did.
Yep.
You get 548.44 on the upper.
So then you got 533.56.
Yep,
Yep.
that's what I got.
Awesome.
Okay. That's what 44 and 533.56. Okay, 12. How does the margin of error for the 95% confidence interval that you computed in part 2 compare to the margin of error for 90% confidence interval that you computed in part 5? So part 2 would be question 8, I think is what they're saying.
Yeah.
So,
Yeah.
great. So
Smaller.
margin of
'cause
error is smaller. Interesting.
Yeah, that's what I was just thinking. I thought it'd be backwards.
Yeah.
I wrote down notes on this too, though, and it says, as level of confidence increases, the width of the confidence interval increases. As the sample size increases, the width of the confidence interval will decrease.
I was just reading that same.
I guess that
Rule.
makes sense.
Because they can be a
So
little bit.
the more confident you are, the more confident, the greater range you have for being confident, right?
Yeah.
Whereas the less confident you are, the smaller the area is in which you can.
The more you
sure
can
that
nail
you
it.
hit. Yeah. I guess you could think of it as shooting a gun at a target. If you're super confident and skilled, then you are certain that you can hit any. I don't know. Maybe I'm weird analogy. Never mind. It doesn't
Love
really
your mind works, Matt. It's cool.
Sounds good to me.
Yeah. Well, we'll just get this over with. All right, it got smaller. Is my answer. Okay, 13. The BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval?
I wrote this down. So n equals z times sigma over m squared, right? Is that what you wrote down, Justin?
Yeah, I was just looking through my notes here. Yeah, right there, to get the desired margin of error.
Yeah.
Yeah.
Because we're trying to figure out the exact n. So
Right.
I'm pretty sure that's what I wrote down.
Yeah, that's what I have written down right here.
Okay, so it would be
Okay, I see that. N equals z times sigma over m squared.
95 is 1.6.
What is m, the margin of error?
Yeah.
N is margin of error.
And we're looking at, what was the percentage again you saw? It was
1.96.
This is what it's going to transfer over to.
Okay, you're right. So 1.96.
N equals.
And we're trying to, and we have 32 is the 8 times 32 squared equals n. So the square root of n equals 1.96 times 32 over 5. Okay, figure that, and then you square it.
What did you get?
I got 157 point.
0.35.
But you always round up because this is a sample.
Oh yeah, so it would be 158.
Yeah. Which is the right answer. Yay!
Awesome.
So 158?
Yeah.
Ashlyn!
Looks like Ashlyn
here.
just joined us.
Hooray!
Hi. You guys are all like in your equation, so I didn't want to say anything.
No, you're good.
So we
Sorry,
think
I'm
we're
late.
done with lesson 11.
Are you good on part 2, Ashlyn? Or do you want us to go over it with you really quick before we take the quiz?
It'll be fine. I think let's just. I don't want to like make you guys wait any longer, so we can just go. And if I have any questions along the way, I'll just kind of ask. But I think I was okay for the most part.
You usually are. You're usually like, bring us back. No.
No, but I don't know. Okay, so we're starting the quiz right now.
Yeah. Are you ready?
Almost. Yes.
My internet's being super slow for some reason. I don't know what's going on.
Okay. Yeah. So I'm like logging into my quiz.
I'm trying to get it to go to the group meeting section so I can start. We'll see how long mine takes.
Load. Come on. Group meeting quiz.
Sorry, I'm not there yet. I'm trying to refresh my page.
Okay.
I think my husband's updating a game, and so it's eating up all my bandwidth.
That's great.
First world problems, right? First world
I
problems.
know, first world problem.
So hang on.
Okay.
I need
It's
a lot.
ridiculous here in Rexburg. Rexburg, it's like pay an arm and a leg just to get okay internet.
Really?
Can't even get really good internet here. Oh.
I'm about to cry. I have to log totally back into iLearn, so hang on one second.
Let's see. So 90% is 1.645?
Yes.
Yes.
And 95% is 1.96, and 99% is 2.58.
Okay. For z-scores. Okay. Let me know when you're in. I'm just going to start working this one out since I'm slow on this lesson.
I think I might have to totally quit again. I don't. I'm so sorry. I'm having like serious technical problems.
okay.
Did you guys notice that I wasn't there for like 5 minutes?
Thought you were just figuring
Yeah.
out stuff. I was just kind
Sorry,
of
just
doing my own
waiting.
little thing here.
I'm so sorry. I
Yeah,
hit
alright.
it and I didn't realize it would take me out of all of my tabs. Apparently that's an obvious thing that people would compute, but not me. Okay, I'm still loading, but if you guys want to get started, I'll just contribute as I can since I'm still getting back into the UI site. It's going a lot faster now, ironically.
Okay, are you guys ready? I can start reading them.
Sure.
Alright, number 3. Find the margin of error for a 90% confidence interval when the standard deviation, sigma equals 50 and n equals 25. Round to 3 decimal places.
So this one we're going to go our z times sigma divided by the square root of n.
Yep,
Right.
so 1.645 times 50
50 divided by square root of 25.
5. I got 16.45.
That's what I got.
Okay. Perfect. Easy button. Cool. So 16.45 for number 3. Number 4, which of the following statements is true? I think x is the point estimator of mu.
Yeah, that's what I have written down in my notes here. That x bar estimates mu for the population mean.
Yeah.
Yeah.
I'm like still loading iLearn. Like I am so upset right now. So I don't know what the options are, but I do have that written down as well. What in the world is going on?
Okay. For number 5, Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation of sigma equals 113. She collects a simple random sample of size n equals 64 and computes x bar equals 526. Use this information for questions 5 through 8. What is the lower limit of this confidence interval? So at 95%, we have z equals 1.960. So you multiply that by 113 and take that answer over 8. And that gives us the margin of error. And then we take 526 minus the margin of error, which is 27.65. So I get 498.315.
498.135?
315.
315.
Sorry, what did you get again?
498.315.
Okay, because we could do the 3.185 minus the 526, right?
Yeah, so 526 minus 27.685 gave us 498.315.
Minus 27.
So to get 27.685, I took 1.96 times 113 over 8.
113. I just typed in 13, not 113. That's where I went wrong.
There we go. Does that give you 27.685?
Yep.
And then you take that and subtract that from 526.
Correct. Okay.
And then, so that gives us 498.315. For question 6, what is the upper limit? So when we take 526 plus 27.685. And I got 553.685. Yep. If the sample size is increased, we talked about this. So what would happen to the width of the confidence interval if Gina increased the sample size?
As the sample size increases, the width of the confidence interval decreases. But oh, right there. Okay.
So the sample size increases, the width of the interval decreases?
Excuse me.
Yeah.
Okay. Making sure I got that correctly.
I'm like still not even in the test. Like I don't even know what to do. Like my computer's just totally locked up.
I'm writing down all the answers.
Thanks.
Yeah.
Totally useless. I've never had this problem before. I went and like looked at his computer. It's not on. Like I have no idea what it's doing on my internet.
It's weird.
I know. I have a password on it. It's not like I'm sharing it with people upstairs.
Yeah.
Oh my gosh.
Okay. You want us to move on to number 8? Okay.
Yeah.
What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
Would that increase? I've got a definition as the level of confidence increases, the width of the confidence interval increases.
That would make sense.
So as level of confidence increases, the width of the confidence interval increases.
Yeah, that's what I have written down.
Okay. Brightbulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is sigma equals 400 hours. They want a 95% confidence interval with a margin error of 50 hours. What sample size do they need?
So
Let's go up.
this is our z times sigma over m.
So it's 95%, so we've got 1.960 times sigma times 400 over 50.
And then square that.
We square that. And that gives us okay, let me do this really quick. Come
I
on.
got 245.8.
We round up. Doing samples.
So it'd be 246.
Wait. So you did 1.96 times 400 over the square root of 50?
No, just over 50, and then you square your answer.
Oh, got it. Okay.
Wait, so you got 245.86?
Yeah, that's what I got. So you'd round up to 246.
Okay. That is for number 9, 246. So 10. Okay, let's see. The mean salary of actuaries is mu equals 100,000, and the standard deviation is sigma equals 36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but I'm not sure if it is higher or lower. You set up a hypothesis test with level of significance alpha equals 0.05, and then you got the two hypotheses. One where mu equals 100,000, and the alternate where mu does not equal 100,000. Collect a simple random sample of n equals 36 women's salaries to find out that X bar is 111,000. Okay. Interesting. This is a tough one. Let's see.
So what would our Z be?
Well, 95%, huh?
Yeah.
So Z is 1.960.
1.96, right?
Yeah. No, sorry. Oh, thank you. Let's see.
Well, if you want to read the question again to me slowly, I can make a contribution.
Okay. I'll give you the numbers. The mu is 100,000. The standard deviation, sigma, is 36,730. And the level of significance is alpha equals 0.05. The null hypothesis. The null hypothesis is mu equals 100,000. The alternate hypothesis mu does not equal 100,000. Simple random sample of n equals 36. They find that X bar equals 111,000. And use it to answer the next three questions. The first question is the lower limit of this 90. What is the lower limit of this 95% confidence interval? We want the nearest whole number.
Did you get the Did you get the answer yet?
I have not. I am struggling figuring out the right equation.
Yeah, I'm trying to figure out what to plug in, like, to what.
Because this is like different from what. This is trying to tie it into the last lesson. I'm trying to find the bridge that connects it. I haven't made it.
So is it the 111,000 plus or minus 1.960 times 36,730 divided by the square root of 36?
No. 11 out of 12 isn't a bad percentage. I'm just kidding. No. Let's see. Did any of you guys figure that out, the equation, or no? I am completely lost.
I think I did it wrong. Dang it.
Okay, so is it 111,000 plus or minus 1.960 times 36,730 divided by the square root of 36?
It might be. I'm sure.
Okay, I think I see what you're saying.
Yeah, because I mean,
Okay.
Because the equation is x bar plus or minus z times sigma over n.
yeah. So I guess you would just be looking at the sample, instead of like the population. So then so then you would maybe do plus or minus.
1.96 times 36,730 over 6, because n is 36. Okay. So, where does the level of significance come into play?
That helps you establish the level of confidence, right? Because when you're at a level of 95, the level of significance is 0.05.
Oh, okay. So it's okay.
Yeah, Sunos, you're right. So it's a 95% confidence.
So that really just tells us that it's at a 95% confidence interval. It has nothing really to do with. It doesn't change our equations that we've
No,
been doing.
it's just sneaky. It just
No.
Gotcha. So that's why I've been so confused. So that's
Yeah,
the tie-in, I
yeah.
guess. But so really, this term
It's
of
the same
95%
thing.
confidence interval is like saying that there's a level of significance of alpha equals 0.05.
Yes.
Exactly. And like they give you an equation for it that makes it a little bit less confusing. It just says 1 minus that alpha is your confidence interval formula percentage. So
Gotcha.
Yeah, 1 minus alpha times 100%.
Okay.
I'm getting like an error code.
Okay.
Every time I try to log into iLearn, it says that there's something wrong with the server. Yep, it's gonna be one of those days. I can feel it.
One of those days. I'm sorry.
Well, in between these, I'm gonna have to like restart my internet and both my computers and see because I'm trying to log onto it on one of my husband's now, and it's the same thing. Sorry. So keep going.
Did you figure it out, Justin?
Yeah, so I get 99001.534.
And then you round up to the whole number, so you got 99002.
Correct.
Perfect.
Okay, I just got that too. So you take 111,000 minus 11,998.4666. Right?
Yeah.
Plus
Yeah,
this one.
correct.
Okay. So it's 99,000.
And 2.
Okay.
Go down. Stay at 8. Because that's a 4.
Okay. And then for the 11, I got 122,998.
Me too.
What'd you get?
122,998.
Okay. So that's with the round to the nearest hole.
Yeah.
Yeah, because it's 0.46. So do we keep the 8 then?
No, because it's 4. If it was a 5, you would round up to a 9.
Okay, so we keep it as 98.
Yeah. And then,
Okay.
do you guys put commas in or no?
I did not.
Okay.
Okay.
How about you, Matt? Did you put commas in?
I did not. I just punched it in as was.
Okay, perfect.
Then for 12, it says there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are.
I know
So
this
this is
one.
back on our.
The SRS population of the standard deviation is known, and then either of these conditions are satisfied. The population is normally distributed, or the sample size n is greater than 30.
It's a gimme question. It's all of the above.
It's all the above.
Yeah. That's funny because they say there are 3 things that you need, and they are, and it's not like a checkbox question. It's a multiple choice question. And it's only got 4 responses. So the only answer really is all of the above. That's kind of funny. Okay.
The only
Cool.
one I could even help with. I'm really proud of myself, though, since I'm still not in the open program.
I know, you did great. Did you want answers to some of the earlier ones to write down so you can just kind of input them?
I've been putting down some notes that you guys are saying. I just restarted my husband's computer, and for his is almost working. It's going a little bit faster, so we'll see if I can get into the quiz.
Okay.
I'm not going to hold my breath.
Yeah.
I wrote them all down too, so.
Oh, look, I'm in. Oh, I just had to restart it like 4 times.
Awesome. So let me know when you're in the quiz, and I'll just read off the answers for you.
Yeah, I'm in. So 3 was
16.45,
16.45.
16.45.
Got it.
4 was x bar is a point estimator of mu.
Got it.
5, 498.315. 498.315.
Thank you. And 6.
553.685.
Thank you.
7 is decrease, I believe.
Yes.
8 is increase.
Awesome.
9 is 246.
246.
10 is 99,002. So 99002.
Got it.
11 is 122998.
Wow. They could have done that like on a smaller scale just to be nice.
And 12 is all of the above.
Yay. Thanks, guys. I made it just for the end.
Submitted. And we got 100%. Woo!
Awesome. Way to go, guys.
All
That
right.
was
And then
long. So let me go ahead and post this, and I'm going to restart my computer and see if I can get it working.
okay, and then you'll call us back.
Yeah, I'll call you guys back. I'll start a new one.
5 minutes or so.
Yeah, it should be about 2 to 5. So I'll see you guys soon.